Hi everyone. So we're continuing with matrices, and this is the last major area, which is transformations using matrices. If we look at Fireboy and Watergirl, and they pass through the portal on the left, what happens is they come out on the right side. And this idea of passing through the portal is handled by your computer or video PlayStation, whatever it is, using matrices. So let's take a closer look. If we look at here, this is a typical Fireboy and Watergirl scenario. We see on the bottom left, Fireboy is there in the lava as usual. And on the top left, here comes Watergirl. And as Watergirl goes through the portal, she now comes out on the right side. Let's see how this connects with our matrices. So if we remove this and we see our grid in the back, Watergirl was on the left-hand side, and when she passed through the portal, she ended up on the right side. So let's see if we can put some axes here. So it sort of links to what is the computer is actually thinking when it's processing your game. So on the left side where she started, we consider that with her starting position to be called the object. And when she moves, it will be called the image. So the object in this case is on the left side, and if we count it, her x value, looking at the origin, -1, -2, -3, and her y value for that position is 1, 2, 3, 4, 5, 6. So water girl as an object is at the point -3, 6. And how did she end up on the right side? That position would be her image after reflection, and that is 3, 6. So what we're seeing is for her to reflect, then there needs to be, let's draw a line from one to the other. We'll see 1, 2, 3, 4, 5, 6 spaces away. So if we want to find the line where reflection is occurring, also known as the line of symmetry, the axis of symmetry, the mirror line, any of those, then if we draw a line from the object to the image and we bisect it, means we cut it exactly in half and we draw a right angle to that, then in this case, the line of reflection or mirror line, let me highlight it, would be our y-axis. So it's easy for us to count when it's straight across. Let's see how we write it in terms of matrices. If we're reflecting about the y-axis, the object, water girl, it will give us the image. So what is the object? Well, we know her values, and it's written like a column vector. So the x value is on top, -3, and the y value is below, which is 6. And there are no commas or anything in between there. So this is a 2 by 1 matrix. And for reflection along the y-axis, if we look at what happens, it started at -3, 6. It ended up at 3, 6. So if we look at our y value, the y value remains the same. That is still 6. So y does not change. If we look at the x value changes from -3 to +3. So it is like multiplying by -1. So how does the reflection about the y-axis represent this? This 2 by 2 matrix looks exactly like your identity, which is 1, 0, 0, 1, except that you're changing the x value. The x value, right? So instead of multiplying by 1, we'll be multiplying by -1, and the rest is the normal 2 by 2 identity. Why? When we're doing that, let's see how we multiply these things. We say we multiply the first row by the column. So minus 1 times minus 3, the blue. And then in the first row, there's still the red, the second terms, which is 0 multiplied by 6. So we have this gives us our first coordinate. And our second coordinate will be the second row, 0, 1 multiplied by minus 3, 6. So 0 times minus 3, the first term by the first term of each, row by column, remember that, and 1 by 6. And now we simply compute minus 1 by minus 3. That's going to give us 3 plus 0 times 6 is 0. And then 0 times minus 3 is 0, and 1 times 6 is 6. So 3 plus 0 is 3, and 0 plus 6 is 6. Therefore, it works that reflecting about the y-axis means really multiplying by a 2 by 2 matrix, minus 1, 0, 0, 1. So the object minus 3, 6 became 3, 6. So we did it practically on your graph paper or graph sheet, and now we're showing it using the matrix method. In the exam, in assessment, when it comes to matrices via transformation, there will be no graph page. So we're using that to support what's happening. All right, so just how we had water girl there, W, we have fire boy. And let's say fire boy is at this position here. The x value is minus 4 and the y value is 2. So fire boy, the object is at that point. And what happens when he's reflected about the y-axis? Now we can do it using the graph page. What we really want is to practice using the matrix method, because that is how we'll be assessed. So reflecting about the y-axis of the point F, the object, it will give us the image. So let's put in the information. We know the object that lies at values minus 4 as x and 2 as y. And we know the reflection, it is the identity 1001, except the x value changes. So we put minus 1001 because we have to change the x value. And if we multiply, it's going to give us first row by the first column would be minus 1 times minus 4, and then 0 times 2. You should practice this so much. And then 0 times minus 4 for the second row, and 1 times 2. And we're going to solve here by computing minus 1 times minus 4, that is 4. And 0 times 2 is 0. 0 times anything is 0 again, and 1 times 2 is 2. So finally, what does that give us? It gives us 4 plus 0 is 4. So, and 0 plus 2 is 2. So what we realize, reflecting about the y point, about the y-axis, means that the x value changes its sign. It moved from minus 4 to plus 4. And the y value remains the same. So it follows there. And if we measure it, we'll see if we draw a straight line from the object of Fireboy FO to FI, you'll see 8 units across, and the mirror line is directly in the middle. There, 4 units to the left, reflected 4 units to the right. And this is reflecting individual points. It is also, if we were given the situation of a straight line, if they gave us a straight line that we had to reflect about the y-axis, then the easiest way to do that would be taking the ends of those lines, which happens to be, in this case, WO and FO. And if we reflect that, then we would get the line on the right-hand side in the first quadrant. So we're doing a couple things. One, we're reflecting by points. And if we were given a line to reflect, then to reflect by a line, we would be taking the ends of the lines and doing the same reflection and then connecting. So this gives us our general rule when we talk about reflecting about the y-axis for any object. It's going to give us some value there. So the object will be x, y, whatever their coordinates are. And when we're reflecting, it looks like the identity, except we're changing the x value. It becomes negative. So it's minus 1, 0, 0, 1. So that will give us minus x and plus y, or y. And similarly, if we had another character in there, let's say that character is at the point x is 1, y is 3, can you now work out using matrices, the matrix multiplication, what the image of that character will be? You can pause the video here and try it. So what we're doing, this is in the application of this in the game, is actually going through portals and moving from one side to the other side. So now that you've completed it, our image should be there, which means that the y value is still the same, but the x value becomes negative 1. Now that also indicates something else. Indicates that if we were given, instead of individual points, a complete triangle as our object, we started here, where we have the object W, O, F, O, and C, O, and we were to reflect that about the y-axis, then what we really need to do is reflect each of the corners. And that would give us the image here. Maybe you'll get a little better view if I remove the axes so you can see it better. That because it crossed the line, it actually intersects. And there's a shorter way to even do this. If we remember that the reflection along the y-axis means we're changing the x value, then we can do all, if there was a triangle or a four-sided figure, we can use the 1, 2, 3, or 4 points and reflect all at the same time, because that is what saves us time in matrices. And I'll give this example here. If we're reflecting triangle ABC, the object on the left-hand side, so it's minus 1, 0, 0, 1, meaning reflecting about the y-axis, and we plug in the points for A, B, and C. A object is minus 3, 6, B is minus 4, 2, and C is 1, 3. And then we have a 2 by 2 matrix, which is the reflective one, and the triangle will be written as 2 by 3. And when you multiply, we're going to get the image of A, B, and C of all 3 points. So it can be done in basically one line. And we can do the same as we go along in all the different types of transformations. I'm just going to do it individually as before, right? But remember that this applies in all. So let's recall that the reason we created this channel is for students who are struggling in the area of mathematics at the CSEC level. And this particular video will be looking at the topic of matrices and specifically transformations, which seems to give students a lot of problems, and even teachers who are having difficulties in bringing the content across to the students. If we look at the description down below, you will see that this is the 4th video in this series on which completes all the content on matrices at the CSEC Math level. And it also shows all the topics of the entire syllabus and the order we suggest you go through it in order to complete the whole syllabus there. This can even be done self-taught for yourselves. We've done the same for CSEC Additional Mathematics from the time it began, which is in 2012 onwards, in terms of all the past paper solutions. And we're on the primary math as well. All those 3 channels are in the links down below. So now we did transformations passing through a portal going left and to right. And now we're looking at the portal going up and down. So if we're thinking about that, instead, this movement now will be vertical rather than horizontal. So let's look at this. And we have our image of the screen. And if we put in here, water girl on the top right side, and she passes through that portal, she comes out down below. So she was up on top and she went down below. So that will not be a reflection in terms of about a vertical axis, but you're actually going down. So that will be a horizontal axis. This will make more sense to us mathematically if we remove this and leave the grid. Then we can see she moved from on top down below. So that was the first quadrant if we're going to put up axes. Second, third, fourth, and she moved to the fourth quadrant. So her information where she started, the object was at the point 36. And by the time she was reflected, she moved down. Her image of water girl will be 3 minus 6. So similarly to what we did just now in terms of reflecting about the y-axis, if we draw a line from one to the other, we will see that in that distance of 12 units, the axis will be in the middle of that at 6 units. And if we draw a right angle to it there, we will see that where does our axis lie? It lies along the x-axis. So in this situation with the portals, they're actually moving from above the x-axis to below the x-axis or across it. So reflection is taking place there. All right. So let's now look at the particular matrices 2 by 2, which will represent such things. So we know we have the object as being 3, 6. We're going to show it here, the multiplication. And what is happening with terms of the reflection about the x-axis? Look at the values. The x value in the object is 3. The x value in the image is 3. So the x remains the same. That is different to the last one. The y value is 6. And in the object and the image, it becomes minus 6. So the y value is now changing, not the x as in the last case. So if we're reflecting about the x-axis, we're writing back our identity, 1001, but we're changing the y value. And in order to do that, we have to use minus 1. So when we do this multiplication, let's go through it and see if we actually get the same value as our graph shows, 1 by 3, the first row by the column, and 0 by 6. And then the second row, which will be 0 by 3. We have them in the same color so you can see it easily. And then the second element of each, minus 1 by 6. So let's go and compute 1 by 3. That will give us 3. And then 0 by 6 will give us 0. 0 by 3 will give us 0. And minus 1 by 6 will give us minus 6. So finally, our answer for the image of W is 3 plus 0 is 3, and 0, which is nothing, you're left with minus 6. So this supports what we're seeing in the graph itself. So water girl movement by portal from on top to below can be represented by this. So when we're doing that and playing our games, this is actually what our video game is being calculated. What about Fireboy? Let's put him here. At that, the object, he will be at the x value of minus 4 and the y value of 1. And when we reflect him, remember we're reflecting about the x-axis. Where does he end up? So let's do the multiplication. Let's try it with the multiplication. That's what we're trying to learn here. Learning it, using it physically with the graph. We have already covered that in those transformation notes on this channel. So that's minus 4, 1. And of course, we're reflecting about the x-axis. So the x value remains the same, but the y value changes. The y value becomes negative. So when we write the identity 1, 0, 0, 1, it becomes -1 to change the value. So it's going to give us 1 by -4 and 0 by -4 0 by 1, 0 by -4, and -1 by 1. Right? Rows by columns, as we've practiced in the second and third videos of the series. So now let's compute. We'll do our computation. 1 by -4, that is going to give us -4. And then 0 by 1 is going to give us 0. 0 by -4 is going to give us 0. And -1 by -1 is -1. So finally, we end up with -4 plus 0 is -4. And 0 plus -1 is -1. So it means that if we reflect this about the x-axis, it's going to go downwards below the x-axis and end up here. So you need to practice this in order to get it. And if you have any questions, put it in the comments down below. So the image of -4, 1 is -4, -1. And this can also be done. We have to open our mind to the idea that they could have, instead of giving us reflecting those points, they could have asked us to reflect this line. And reflecting this line, for us to do it, we can reflect the two ends of the lines and do the same working, and we'll end up with this. Right. So now we give you a third point for you to try by itself, but remember, let's look at the general principle for reflecting about the x-axis. That if we reflect about the x-axis any object, what's the image we're going to get? Well, think of an object xy. And what is the 2 by 2 matrix that represents this? Exactly the identity 1, 0, 0, 1, except we're changing which value? The y value. So 1, 0, 0, -1. And our solution, which will give us our image for whatever object we're doing, will end up with 1x and -1y. So the y value is changing. Can you try this point here for a third character? We have Fireboy, Water Girl, and let's put a third character here. She is at 1, 2, 3, 4, 5. So this character is at 5, 2. Pause the video and use your matrix multiplication and work it out. And now that you're back, you should be getting some value here, which we can see it was 2 above the x-axis, so it'll be 2 below the x-axis at these coordinates, 5 minus 2. Of course, this is also mimicking the idea that maybe they had given us a triangle in order to reflect. And in order to reflect the triangle, what we should be doing is reflecting the 3 corners. And that will give us these 3 corners as the image. On our first, when we did reflection of the y-axis, I showed you could do it in one matrix multiplication, the Rx times all 3 points. Write it out as a 2 by 2 by a 2 by 3 and solve it in one. Let's now look at the topics in CSEC Math. And even with the change of the syllabus, these are still the 10 major areas. And we are looking at vectors and matrices. Since it has gone to a modular format, Module 1, there's no topic on vectors and matrices, but in Module 2, vectors and matrices are assessed where 4 marks are given in paper 1 in the multiple choice, and 4 marks are given in the paper 2. So if you're writing Module 2 alone, you expect to get 4 and 4, 8 marks being assessed on this topic number 9. And if you're writing Module 3, there are 3 multiple choice questions on it and 9 marks in long paper, paper 2. Of course, if you're writing Module 2 and 3 together, or all 3 modules together, according to what your choice is, Then it will be 4 and 3, 7 multiple choice marks and 13 long paper marks. So we're specifically looking at matrices, which will be a portion of those values. So let's look at reflection across the line y is equal to x. We already did it for the straight lines of being vertical, the y-axis, and across the horizontal, the x-axis. And as we're following your syllabus, there are 4 situations, and the third is reflecting about the line y is equal to x. And remember, y is equal to x is really if x is 0, y is 0, so it passes through the origin. If y is 5, x is 5, so we could get 2 points and draw a straight line. So let's consider water girl to be at this point here, 2, 6. And we're reflecting it about, not the y-axis, not the x-axis, but about the line y is equal to x. That's her mirror line. So where will she end up? Well, if we were doing it by the grid format in terms of a graph paper, as we have done in previous videos in that topic of transformation, then we would basically be drawing a line perpendicular to the mirror line. And if we check the distance, 1, 2 away, so 1, 2 away. As such, your image for water girl after she has passed through the portal will be she ends up at the point 6, 2. So let's look at those ideas here when we talk about reflection about the line y equal to x. For some object, we know that x in this case is going to be 2, 6. And when we're setting up the reflection matrix, it always stems from the idea of something similar to the identity, which is 1, 0, 0, 1. What is happening here? Let's look at what's going on. It started the x value at 2, and it became the y value for the image. The x value for the object is 6, and the x value for the image is 6. So now that we realize the x and y values are switching, how do we use the 2 by 2 matrix to switch the x and y values? Well, if we start at 0, 1, and then 1, 0, that should do it for us. So let's see, let's look at the multiplication. When we do the multiplication, it'll be the first row by the column, which is 0 times 2, and 1, which is in red, times 6. Rows by columns, first term by first term, second term by second term. If there was a third term by third term, which will actually be three-dimensional, which happens at A levels. So this is the scenario here, and then second row by column, so we'll get 1 by 2, and in the red terms, which are the second terms of each, for the row 1 column, 0 by 6. Let's compute it, and when we're solving the simple computation, 0 times 2 is 0, and 1 times 6 is 6. 1 times 2 is 2, and of course 0 times 6 is 0, which simplifies to 0 plus 6 is 6, and 2 plus 0 is 2. As such, what it's saying is that it agrees with what we have done physically on the graph page, that the point 26, when it was reflected about the line y equal to x, became 6, 2. The x and y values switched by using this matrix 0, 1, 1, 0. Let's try another point. Let's say this is for Fireboy. He will be at the point -4, 1. And when he's reflected across that line y is equal to x, where is he going to end up? Well, let's practice because we have to learn this matrix method. Let's set up the matrix multiplication. Reflection about the line y equal to x for that object, Fireboy, before he becomes the image, the movement across the portal. So that's -4 is the x value, and 1 is the y value. And when we look at the reflection about the matrix, very similar to the identity, but because we're switching terms, it becomes 0, 1, 1, 0. And what does that give us? When we do the multiplication, we are going to get 0 times minus 4, and then we're going to get 1 times 1, second term by second term, row by column, 1 by minus 4, and 0 by 1. So 0 by minus 4, that gives us 0. And then we have 1 by 1, gives us 1. 1 by minus 4 gives us minus 4. And 0 by 1 is 0. So let's solve the two additions, 0 plus 1, that's 1. And minus 4 plus 0 is minus 4. So let's bring that up. X is 1, y is minus 4. So the image for Fireboy, when you came across this, is 1 minus 4. The terms have switched. And let's see if it's correct. If we draw a line straight across, and in the middle of it, we have a perpendicular line, it is y is equal to x. So of course, this means that if they had given us a line from WO to FO and asked us to reflect that about the line y is equal to x, we would just do the same reflection about the two endpoints, and which would give us our image WI and FI. So that line would be reflected there. So generally, what does this mean? It means that when we're reflecting about the line y is equal to x for some object, and we have the object, generally it will be called xy, those are the coordinates, then what's going to happen is we're going to use a 2 by 2 matrix to switch the terms, so it's 0, 1, 1, 0. Then what is our solution? Our answer will be where the terms had switched the values. So whatever the y value was, that now becomes the x value, and the x value becomes the y value. So minus 4, 1 becomes 1 minus 4. And let's let you try one more. If there's a third character in it, where this character is at minus 4, 6. Pause the video here and go and do the matrix multiplication for reflection about the line y equal to x. Right, now that you're finished, you should be getting it at this point where the image of that character is 6 minus 4. Minus 4, 6. Switched around is 6 minus 4. And of course, that really meant that we could have gotten a question looking like a triangle and asking us to reflect it about that line. And when we reflected it, we would have gotten the green triangle. Right? Maybe if you draw this across, you can see that all of them, when you connect the middle of it, the perpendicular line is y is equal to x. Even if we move this here, you can clearly see that. I give you the reflection a little easier. We take these off as well. We can see that reflection. Let's now look at the reflection across the fourth situation for this syllabus when y is equal to minus x. So let's pull up the same grid again and put in the axes as well. And the line y is equal to minus x is a negative gradient. So the line, if it's starting on the left, will be going downwards. And y is equal to minus x is there. Let's go through the values. If we have water girl starting here at 2, 6, and she is being reflected across that line, where will she end up? So we can draw a line which is perpendicular to the axis and the same distance away, 1, 2, 3, 4 diagonals from the boxes, 1, 2, 3, 4 diagonals again, means that here would be her image. So image will be at 1, 2, 3, 4, 5, 6. The image will be at minus 6, minus 2. So if we're doing a reflection about the line y equal to minus x for the object of the water girl, WO, it will give us WI, the image. Now we know WO is 2, 6. Let's see how we're going to work that out in order to get a particular one in which it gives us the right image. So let's look at the answers. What happened? The 2 and 6 switched just as when the line was y is equal to x. But they also, both of them, apart from switching, they changed signs. So we want them to switch, but we also want them to change signs. So it's going to look very similar to the 0, 1, 1, 0 just now, except it's going to be negative for both of them, because we also want the negative answers for them. So let's go through it and see. Rows by columns again. So it'll be 0 by 2, the first row by the column, first item by first item, blue by blue, and then second item by second item, the red by red, minus 1 by 6. Trying to color code it so you can see it. Then the next row is first item, minus 1 by 2, which is in blue, and then the second by the second, 0 by 6. And let's simplify this computation here. 0 by 2, that's going to give us 0. And then minus 1 by 6 is going to give us minus 6. And then minus 1 by 2 is going to give us minus 2. And finally, 0 by 6 is 0. So as we're solving these two additions, they're going to give us minus 6 and minus 2, which is exactly what the image has shown us for Water Girl as she teleported across through the portals. Let's try for Fireboy. Let's put him at some point here. And Fireboy is at minus 4, 6. Let's go try and do the matrix multiplication. Set it up the reflection about the line y is equal to minus x for the object Fireboy will give us the image of Fireboy after he's reflected. So we have minus 4, 6 as being his x and y coordinates. And then the reflection is very close to 0, 1, 1, 0. The signs also have to change. So 0, minus 1, minus 1, 0. So very similar, but because we're changing the signs, we have to put the negatives involved. And as we see, that will give us first row by first column, 0 times minus 4, and second item by second item, which is minus 1 times 6, and then minus 1 times minus 4, and 0 times 6. Let's simplify now. So that will give us 0. Minus 1 times 6 is minus 6. And then we're going to get minus 1 times minus 4. And that's going to give us 4. And finally, 0 times 6 is 0. So we're ending up with minus 6. And 4 plus 0 is going to give us 4. So if that's the case, look at where Fireboy is before he's teleported, minus 4, 6. And when he flips across the line, he ends up there at minus 6, 4. And if that's correct, let's draw a line through there, and the middle of it, when we bisect it, the perpendicular line is y is equal to minus x, so it works. And of course, this means that if they had given us a line from WOFO to reflect about y is equal to minus 6, it will be this line WIFI. So the general principle here, when we're reflecting about the mirror line, y is equal to minus 6 for some object whose general coordinates are x and y. Remember that we're using something very close to reflecting about the line y is equal to x, 0, 1, 1, 0, but we have to change the signs. So it'll be 0, minus 1, minus 1, 0. And that will give us minus y as our x coordinate and minus x as our y coordinate. And finally, I'll give you one to do. If we consider we have a third character apart from Fireboy and Water Girl, and they're at that situation where x is 3 and y is minus 1. Pause the video here and you go and work out the matrix multiplication. So where does that end up? Do it by a handwritten method first. And of course, what that gives us is the point here where the values switch and they change signs. So instead of -1, it becomes +1. Instead of 3, it becomes -3. And if we draw a line through there, that tells us that where the bisecting line is the mirror line. And as we said before, they could have given us a triangle. In order to reflect the triangle, we take the 3 corners and do the reflection about the line so we can see it. And if we move the axes, maybe we see it a little better. Let me remove these as well. Then you can see that. Now, remember we said that from the first slide I showed you, you can actually work out all 3 at the same time by using the reflective matrix 0, -1, -1, 0 by all 3 points. Since we've completed that, let's think about if we had our object in our game, and when it hits a pointer, it stretches and it gets wider. So imagine we have a shape like this in our video game, and when we hit a particular bonus, what it causes us to do is to get wider, to expand horizontally. So if we look at this shape here, we have basically, it starts at the origin, it goes up to the highest point, the top 2, 3, it goes to the extreme right at 4, 0, because it's on the same x-axis, and then it returns and so forth. So what happens if we actually now cause it to grow to the right, to get wider? And let's consider we're going to get it 3 times wider. Well, it'll be expanding from 4 at the base to 8, that's double, 11, 12. So it's gotten 3 times wider. If we look at that, the right side, most 0.40 went to the end at 12, 0. The highest point, the top at 2, 3, it moved to the right 3 times to 6, 3. But nothing went up. So what it shows is that by growing to the right, or getting wider, it's really an extension in the x direction. And if we look at the original point, 2, where it has extended by a width of 3, what is changing? The y values are remaining the same, but of course the x value is changing. In this case here, we use a scale factor of 3 for it to get 3 times as large, which means if we look at the top point of this original shape, it was at 2, 3. And by the time we extended it, it moved. The x value alone is moving. So it was still writing a matrix which looks like the identity 1, 0, 0, 1, except the x value is now 3 times that amount. So it'd be 3, 0, 0, 1. So when we do the multiplication, as usual, we'll be multiplying rows by columns. So we get 3 by 2 is 6, and then 0 by 3. And then second row by column, which is 0 by 2, and of course 1 by 3. What does that give us? It gives us, when we're doing the computation, 3 twos are 6, and then 0, 3s are 0, 0 twos are 0, and 1 3 is 3. As such, 6 plus 0 is 6, and you can see that, and 0 plus 3 is 3. So the top point, which was 2, 3, when it got 3 times wider, became 6, 3. Look at the coordinates, and you can see that we can expand accordingly. Even at the point on the extreme right, when we looked at that point, at the original shape, it was 4, 0. The x value was 4, and it's resting on the x-axis, so the y value is 0. And if we multiply by the matrix, which is stretching it in the x direction, making it 3 times wider, then we're going from the origin and we're stretching out to the right. Then we're using the same thing, very similar to the identity 1001, except the x value needs to be 3 times as much. So it'll be 3001. And when we do the multiplication, it's still rows by columns as usual. So it'll be the first row by the first column, 3 by 4, the first term by the first term, and then 0 by 0, followed by 0 by 4, and 1 by 0. So simplifying, we're going to get 3 fours are 12 plus 0, and 0 fours are 0. And finally, 1, 0 is 0. So we're finding the coordinate of the extreme right point where it was originally at 4, 0. And by the time the shape got 3 times wider, then it will be at 12, 0. And we can see that in our shape. So generally what we're saying is that if we write the general expression for such things, we'll get e times 0, and e being your extension or your stretch, let's put it that way, for xy, and that will be whatever value we're making it wider, 3 times, 5 times, maybe shrinking it a half times the amount, the x value will change. If we wanted to go in the other direction, it will even be a negative. So that will give us the x value alone changing will be whatever that value is, k x times x, and the y value remains the same. Now let's look at hitting a token, and you're now in your game getting taller. You're growing vertically. Let's now consider that we hit another token where in this case it causes our icon, our character, to grow vertically. So imagine this causes us to grow 3 times as tall. So we are at the origin, and it's 3 times further away from the x-axis we are getting. The points on the x-axis at 0 and 4, if they're getting 3 times that, will still be at the same point. However, the height, the tallest point at 2, 3, should grow 3 times higher. Let's see. And it's growing from 3, it's going upwards. The circles or the eyes of this shape are stretching taller and taller until it stops at 9. So it was 2, 3, and it now went to 2, 9 as the tallest point, T. The point on the extreme right, 4, 0, still remained at 4, 0. So if we're elongating it or stretching it along the vertical point in terms of the y direction, then we have our original point at the top, which is 2, 3, and we're stretching it. Let's say we stretch it how much? 3 times higher. Then it looks just like the identity 1001, except we're now making it not the exact, but the y value has climbed. So it'll be 1, 0, 0. And in this case, we're stretching it by a scale factor of 3. So 1, 0, 0, 3. So when we work that out, we're going to get 1 by 2. And then we're going to get 0 by 3. First row by first column. Now second row by second column. 0 by 2. And 3 by 3. So we're going to get 1 by 2 is 2. And 0 by 3 is 0. 0 by 2 is 0. And 3 threes are 9. So that means that our final point, the image of that top point as it moved upwards because it grew taller, is 2, 9. And we can see that there. It agrees. Let's look at the extreme right point of that original shape, where we have the values 4 and 0, and then we're stretching it in terms of height. So the y value is going to get bigger. 1, 0, 0, not 1, but 3, because we're going to make it 3 times taller. So it's going to get 3 times further away from the y-axis. So what is it going to give us? It's going to give us 1 by 4 and 0 by 0, and then 0 by 4 and 3 times 0. So it's going to give us 1 by 4 is 4, and then 0 by 0 is 0, 0 by 4 is 0, and 3 by 0 is 0. So that's going to give us a total of 4 for the x coordinate as it moves, and the y coordinate is 0, because 3 times 0 is 0. As such, the general formula for this is E, our extension in the y direction, times our object, which is x, y, as our general points, and we're stretching it. But what we're stretching in the y direction, the x value doesn't change, so it's still 1, 0, 0, but the y value changes by whatever scalar factor, whatever constant there is. It's only affecting the y value alone. So it'll give us 1 by x is x and ky by y. Now imagine we're stretching to get both wider and taller at the same time. Let's consider the entire object by hitting a different bonus grows 3 times larger, just as when we saw in one of the earlier videos where Pac-Man, when he ate pellet, he become 4 times bigger. In this case, we're going to do it 3 times, and we're using the graph here to show exactly what's happening. What do you think will happen to the point on the extreme right at 4, 0 when it gets 3 times larger? Where will it end up? And where do you think the top point at 2, 3 will end up when it's 3 times larger as well? So let's now see what happens as it's growing in both horizontally and vertically. It's now double the size, 2.5 times the size until it's 3 times the size. And at 3 times the size, the point 40 will go to 12, 0. And the highest point, which is 2, 3, it will be multiplied by 3. So it'll be at 6, 9. If we now think of extensions in both the x and y directions, both wider and taller, let's look at the top point. Top point is 2, 3. And when we're extending it, in this case, we're extending it 3 times in terms of width and height. Then the x value, instead of 1001, the x will make it 3 times more, 30, because we want to get the x 3 times higher. It's a combination of width and height growth, and 3 times the y value, 3003. So that is really telling us 3 times 2, and then 0 times 3, 0 times 2, and 3 times 3. So this one is a combination of both. So according to what game you have, you know you grow different ways accordingly. So 3 2s are 6, 0, 0, and 9. So you're going to get 6 and 9 as your new point. If you look at it, you will see it there in our diagram. And now let's look at the extreme right point. Right? So when we go through the same format, that was at 4, 0, and we put in our coordinates. Remember, we're stretching it in the x direction, 3 to the right. So it's 3, 0, 0, and 3 up. So it's 3 4s are 12, and 0 by 0, 0, 0 by 4, and then 3 by 0. So that's going to give us 3 4s are 12, and 0 zeros are 0, 0 4s are 0, and 3 zeros are 0. So when we're stretching it, we're pulling it to the top right, pretty much. That point which is on the y on the x-axis doesn't come off. It's still 12. It just moves to the right, 0. So this matches our diagram. So if we're elongating to the x and y, so we're stretching it pretty much, the object to get the image, our object which has general coordinates x and y, will be stretched by some scalar factor k, 0, 0, and y will also be stretched by the same k. And of course, this can be rewritten xy, and we can factorize out that k, right? And if we factorize out that k, what are we left with? We're left with 1, 0, 0, 1. And of course, what is 1, 0, 0, 1? That's the identity. And if we're multiplying by the identity, does anything change? It does not. As such, what we're really saying is k, the scalar factor that we're multiplying by, times x and y. And we've done scalar multiplication before, even in the first of these 4 videos covering matrices, which really tells us the answer is kx and ky. And if you looked at it, for the top point, which is 2, 3, when we use the scalar factor of 3, our new image for that point is 3 2s are 6, 3 3s are 9. And for the extreme right position, where it is 4, 0, 3 times that, 3 4s are 12, 3 zeros are 0, 12, 0. So it makes sense. Now, imagine we're going to be rotating. So if we have some video game version, I'm just going to shortcut it and pull up the grid. And imagine we have a point 0, 6. We're lying on top of the y-axis at the point 6. Let's say that's Water Girl. And when she got this token, she was able to turn about the origin. If she was able to turn a quarter turn, she went to minus 6, 0. So we're going to look at turning or rotating in these video games and what analysis is happening and what matrices is working behind to get the new image. So how does this operate? Well, we know that Water Girl will be 0, 0, 0, 6, sorry, because it's what started off originally on the y-axis. And in terms of rotating however many degrees, then it follows, because it's an angle, then it follows cos theta minus sine theta, cos theta. And we're rotating in a counterclockwise or anti-clockwise direction. So in this case, we're rotating 90 degrees. We could have been rotating 38 degrees. We just plug in cos 38. In our case here, for 0, 6, we're using 90. So cos of 90, that is 0. Sine of 90 is 1. So we have minus sine of 90. So that's minus 1. Sine of theta, which is 90. Sine of 90 is 1. And cos of 90 is 0. So what we're doing is, because we're rotating 90 degrees, we're plugging in 90 degrees there. And now we have our 2 by 2 matrix. And now, of course, we do the standard multiplication, 0 by 0, and second item in the row by second item in the column, minus 1 by 6. And then second row, first by first term, 1 by 0, and second term by second term, 0 by 6. So that gives us, by simplifying, 0 zeros are 0, minus 1 by 6 will give us minus 6, 1 by 0 is 0, and 0 by 6 is 0. So our final answer, which gives us our image, is minus 6, 0, which holds from what we've seen there. What about if we're turning a Fireboy who's at this point, which is -4, 6, and he's also turning 90 degrees? Well, let's see if we can use our matrix multiplication and practice it to see where he ends up. So we know he's at -4, 6. That's the object where Fireboy is starting. And he's rotating and he's following, let's write the formula, cos theta minus sine theta, cos theta. And if it is 90 degrees, then we know for -4, 6, it's going to be multiplied by cos of 90, which is 0, and then -1, 1, and 0. And if you go through this, we're going to be multiplying, so 0 times -4, and then -1 times 6, 1 times -4, and 0 times 6. So it'll give us 0 times -4 is 0, 1, they get -6, 1 times -4 is -4, and 0. So that will give us -6 and -4. And that point will fall into the first, second, third quadrant. And if we rotate it, there it is. So that is our rotation of 90 degrees. And of course, if they give us a straight line to rotate from, which would be WO to FO, we would calculate the values for the ends and reflect them, and we'll end up with this line. The line has rotated 90 degrees in a counterclockwise direction or 270 degrees in a clockwise direction. So generally, the rule of thumb for when we're reflecting 90 degrees or any angle accordingly, where it's X and Y, then we're using the general formula here, cos theta minus sine theta, cos theta. If it's 90, you substitute. If it's 45 degrees, substitute accordingly. So I want you to try a third character. So if there's a character here based at the point 2, 3, and it's rotated 90 degrees, where will it end up? So you can pause the video and go and work out the multiplication. Cos theta minus sine theta, cos theta. Substitute theta as 90 degrees. Right? In this case, we're using all three at the same rotation, 0, -1, 1, 0. And that will end up, let's show the rotation here, from the origin, and it's turning 90 degrees. It ends up there, at the point where the image of that character is, -3, 2. So that's really saying that if they gave us a triangle and they ask us to rotate it 90 degrees, then our answer would be we're rotating each of the corners, and it would be our images now. And if we connect the three images, we will get that green triangle. And this is our final transformation, translating, meaning that the object in our video game is sliding. So SL for sliding, SL for translating. So we're just going to bring up axes quickly and say if we have some point here, the water girl is at -2, 4, and she slides 1, 2, 3, 4 to the right, and 1, 2, 3, 4, 5 up. Then she will move to this point. And that point is 2, 1. Let's look at the transformation using matrices. It is really, when we're doing transformation, unlike translation, this is the only one of the transformations where its addition is taking place, while the others are all multiplication. So what did we translate? We know WO, water girl in its original position, being the object, is at -2, 4. And then what's the translation? Translation is 4 to the right, 5 up. So we're doing an addition, and that simply gives us 4 plus minus 2, which we've done in the first video showing addition of matrices, and 5 plus minus 4. And that will give us 2, and 5 minus 4 is 1, 2, 1, which is what our diagram shows. What happens if Fireboy now is at the point minus 4, 1? Can you use your addition of translation? We're translating the same point here. Then work it out. Let's go through it. Translating Fireboy as an object into its image. So we know Fireboy is minus 4, 1. And the translation is the same for this question here, which works out to be 4 to the right. So it's plus 4, 5 up, which is plus 5. And that is going to give us, adding the top terms, 4 plus minus 4, and 5 plus 1. So that's given us 4 plus minus 4 is 0, and 5 plus 1 is 6. So if we look at our green arrow, it should follow the same movement to the right and up. So let's slide it across. And therefore, at this point, it is our image of Fireboy after he has moved to 0, 6, which matches with our calculations. So if we had a line and they ask us to translate the line, we would calculate the corners and then connect the dots. So the whole line slid 4 to the right, 4 units to the right, and 5 units up. So let's look at the general way of representing this. If we have an object and we're going to translate it, translation plus the object. So we know the object is generally xy as the coordinates, and we have the translation with some values a and b accordingly. Then we're going to do addition, and our image is a plus x and b plus y. So let's look at the third character, c at the object of 1 minus 1. I'll pause the video now and use your matrix calculation, addition of the translation vector, which is 4, 5, and see where does its images. Now that you're back, the image would be such that it would be moving just as the green arrow, 4 to the right, and then 5 up. So the image of the character will be, at this point here, 5, 4. And what this really says is that they could have given us a triangle and ask us to translate it for 5. And what we'd be doing is calculating each of the corners, and we would get that object. So this brings us to the end of the matrices content, part 4, where we looked at transformations in terms of rotation, translation, enlargement, and reflection, and followed the syllabus requirements. So you can add any comments down below and like the video. Don't forget that this series and all the playlists in order to cover the entire CSEC Maths syllabus is highlighted in the description down below, as well as the 3 channels for you to get help. Our next video will be matrices past papers, and there are 3 of those videos from May 2009 to 2013, 1 video on those matrices past papers, then 2014 to 2018, and 2019 to 2022. So 14 years of past papers will cover all our content. Take care. Bye.